ठीक है, और मैं आईआईटी रुड़की से ग्रेजुएट हूँ, ठीक है, और इसके अलावा टाइम के साथ बताता रहूँगा कुछ कुछ, ठीक है। तो आज क्या पढ़ने वाले हैं? वेव ऑप्टिक्स, ठीक है। आई थिंक आई विल स्टार्ट विथ YDSE, stands for Young's double slit experiment, ठीक है। YDSE बोलते हैं यूजुअली, ठीक है। दिस इज लाइक द सेंट्रल पार्ट ऑफ वेव ऑप्टिक्स, ठीक है। दिस इज द मोस्ट इम्पॉर्टेंट पार्ट। हाइगन्स प्रिंसिपल भी होता है, बट फ्रॉम द पॉइंट ऑफ व्यू ऑफ एग्जामिनेशंस या कम्पिटिटिव एग्जामिनेशंस, हाइगन्स प्रिंसिपल इज नॉट अ वेरी डिटेल्ड, मतलब डिटेल में नहीं पूछे जाते उस पे क्वेश्चंस। इट्स लाइक कि बहुत सिंपल थियोरेटिकल क्वेश्चन होगा कि हाइगन्स प्रिंसिपल पे, ठीक है। सो विल कवर दैट लेटर ऑन। दिस इज द मोस्ट इम्पॉर्टेंट पार्ट, ठीक है। दिस इज लाइक इफ यू आर गिविंग एनी एग्जाम, डज नॉट मैटर कि आप अगर मेडिकल दे रहे हो या आप इंजीनियरिंग दे रहे हो, वट एवर मे बी द एग्जाम, दिस इज वेरी इंपॉर्टेंट, ठीक है। एंड वाई इज दिस इम्पॉर्टेंट? क्योंकि ऐसी कुछ कहानी होती है, लाइट का क्या नेचर होता है? पार्टिकल एंड वेव, ठीक है। सो दिस एक्सपेरिमेंट इट वेरीफाइड द फैक्ट कि लाइट हैज अ वेव नेचर, ठीक है। दिस इज व्हाई इट इज इंपॉर्टेंट, ठीक है। देयर आर अदर एक्सपेरिमेंट्स व्हिच प्रूव्ड दैट लाइट हैज अ पार्टिकल नेचर, ठीक है। बट YDSE, Young's double slit experiment, it is important because it proved that light can be explained as wave nature, ठीक है। तो let's get started. Oops, ये रुकता नहीं है क्या? नहीं, कोई बात नहीं, कोई बात नहीं, कोई नहीं, I will take it. ठीक है। तो बिफोर वी बिगिन Young's double slit experiment, I just want to do a quick background of multiple things that we will be using in this, ठीक है। तो आई थिंक आप लोगों ने क्लास 11th में वेव्स नाम का चैप्टर पढ़ा होगा, वेव्स, ठीक है। तो व्हाट इज द इक्वेशन ऑफ अ ट्रैवलिंग वेव? कैन यू टेल मी? y is equal to a sin, are you sure this is a traveling wave? Have a look. Is this a traveling wave? भूल गए? रिवीजन कर लिया करो कभी कभी गलती से। This is not a traveling wave, sorry. Any other guesses? बताइए बताइए, थोड़ा सोचिए, दिमाग को टटोलिए अपने, बताओ, याद करो कुछ भूली बिछड़ी बातें। बोलो। इक्वेशन ऑफ अ ट्रैवलिंग वेव, ठीक है। आई विल नॉट गो इन टू अ डिटेल्ड एक्सप्लेनेशन राइट नाउ, बट मैं आपके लिए बता देता हूँ। दिस इज द इक्वेशन ऑफ अ ट्रैवलिंग वेव। वेव पता है सबको क्या होती है? वेव क्या होती है? कैन यू डिफाइन वेव इन अ सेंटेंस? बोलो, चुप क्यों हो? याद नहीं है? भूल गए? ठीक है, तो लिखो, आप लोग लिखो। A wave is the transfer. A wave is the transfer slash propagation of energy. A wave is the transfer slash propagation of energy slash disturbance of energy slash disturbance from one point to another, from one point to another. ठीक है, तो सबसे क्लासिक एग्जांपल ऑफ अ वेव इज कि यू हैव अ फाइल ऑफ स्टूडेंट्स, ठीक है, गोइंग टू असेंबली, बताया होगा ये। तो सबसे पीछे वाला बच्चा अगर धक्का देगा तो आगे तक धक्का जाता है, ठीक है। तो व्हाट बेसिकली हैपेंस इज फॉर अ वेव, सबसे पहले पीछे वाले बंदे ने धक्का देने के लिए ऐसे हाथ आगे करा, ठीक है। नाउ व्हाट इज हैपनिंग इज कि ये धक्का इसको जाएगा, ठीक है। कैसे जाएगा धक्का? व्हेन कोलाइड होंगे, अगर मेरा हाथ लग रहा है किसी के ऊपर धक्के के लिए, देन आई एम गोइंग टू कोलाइड माय हैंड्स विद देयर बॉडी, ठीक है। तो कोलिजन होता है तो क्या होता है, एक इंपल्स लगती है इसके ऊपर आगे की तरफ, नहीं लगती। कुछ याद है इंपल्स? क्लास 11th इंपल्स तो याद होगा। इस पे इंपल्स लगेगी तो इंपल्स फॉलोज न्यूटन्स थर्ड लॉ ऑफ if A applies a force on B, then B will apply an equal and opposite force on A, ठीक है। तो इसके ऊपर पीछे को इंपल्स लग जाएगी, ठीक है। Now what is going to happen is subsequently ये सीधा हो जाएगा और इसके ऊपर इंपल्स लगी थी तो अब ये ऐसे टेढ़ा हो जाएगा, ठीक है। एंड दैट इज गोइंग टू कीप हैपनिंग, आई होप यू कैन अंडरस्टैंड दैट, ठीक है। फाइनली व्हाट इज गोइंग टू हैपन इज कि ये जो आपका फाइनल वाला स्टूडेंट होगा, he will be like this, he will be disturbed, ठीक है। तो you can understand कि disturbance originally यहाँ पे थी, now that disturbance has reached here, ठीक है। this is a wave, energy disturbance are same thing, ठीक है। अब आपको अगर ये याद आ रहा है कि ये ट्रैवलिंग वेव है, दिस इज द इक्वेशन ऑफ अ ट्रैवलिंग वेव, तो हाउ इज अ ट्रैवलिंग वेव डिफरेंट फ्रॉम अ स्टैंडिंग वेव? स्टैंडिंग वेव का एक बहुत क्लासिकल एग्जांपल होता है गिटार स्ट्रिंग, नहीं भूल गए? ऐसे एक गिटार की स्ट्रिंग है, यू कैन हैव अ स्टैंडिंग वेव लाइक दिस, मल्टीपल हो सकते हैं, बहुत सारे आइटरेशंस हो सकते हैं इसमें, नहीं समझ में आया आपको? ऐसा भी हो सकता था कुछ, ठीक है, बहुत केसेस होते हैं। तो बेसिकली स्टैंडिंग वेव क्या होती है? स्टैंडिंग वेव में एनर्जी इज लॉक्ड बिटवीन दिस पॉइंट एंड दिस पॉइंट, ठीक है। एनर्जी इज नॉट बीइंग ट्रांसमिटेड, एनर्जी इन दोनों पॉइंट्स के बीच में लॉक है, ठीक है। व्हाट इज गोइंग टू हैपन इज कि अगर मैं इस वेव की बात करूं, स्टैंडिंग वेव की, तो ये धीरे धीरे ना, ये जो ऊपर वाला पार्ट है ये नीचे आएगा, ये जो नीचे वाला पार्ट है ये ऊपर आएगा, ठीक है। थोड़ी देर बाद कुछ और थोड़ा ऐसा हो जाएगा, ये थोड़ा और थोड़ा ऊपर आ जाएगा, ठीक है। एंड फाइनली व्हाट यू विल हैव इज जस्ट दिस स्ट्रेट लाइन फॉर अ मोमेंट, ओनली फॉर अ मोमेंट यू विल हैव ओनली अ स्ट्रेट लाइन, ठीक है। और फिर से आप सोच सकते हो कि अब ये थोड़ी देर बाद ऐसा हो जाएगा और ऐसा हो जाएगा। ये समझ में आया आपको? कुछ याद आया? पुरानी बातें पक्का अटेंड करा है ना सबने वेव्स? पक्का? चुप क्यों हो? यस सर, क्या याद है कुछ पुराना? नहीं याद है तो बोल सकते हो आप लोग, बोलो बेटा। ये याद है कुछ ऐसा होता था, ठीक है। तो इसमें एनर्जी ट्रैप रहती है, ठीक है। ट्रैवलिंग वेव में एनर्जी प्रोपगेट करती है फ्रॉम वन पॉइंट टू अनदर, अभी हमने जो देखा, ठीक है। ये वेव प्लस एक्स में जा रही है या माइनस एक्स की तरफ जा रही है? इज दिस वेव ट्रैवलिंग टुवर्ड्स द पॉजिटिव डायरेक्शन ऑफ एक्स और द नेगेटिव डायरेक्शन ऑफ एक्स? This wave is traveling towards positive direction of x, ठीक है। If you want a wave which should travel towards the negative direction of x, you will choose y equal to a sine kx plus omega t plus phi, ठीक है। प्लीज इसको ध्यान रखना, दिस इज traveling towards minus x, this is traveling towards plus x, ठीक है। मिटा दूं, ठीक है। प्लीज रिवाइज कर लेना एक बारी आप घर जाके वेव्स का चैप्टर। इस टर्म को क्या कहते हैं? Initial phase, not phase. This is called initial phase, this particular term. This complete term in the bracket is called phase, ठीक है। छोटी बातें हैं ऐसे, I know, but I'm just going through it again. लिख लिया सबने? मिटा दूं? हाँ, ठीक है। तो अब आपको ये बातें कुछ कुछ शायद याद आई हूं, ठीक है। अब आप एक बात बहुत मतलब आई थिंक आसानी से आप समझ पाओगे। अगर एक वेव है विच लुक्स लाइक दिस, ठीक है, और एक और वेव है विच इज एब्सोल्यूटली आइडेंटिकल, इन दोनों के लैम्डा की वैल्यू सेम है, वेवलेंथ की वैल्यू सेम है, ठीक है। एंड आप प्लीज लॉक कर सकते हैं गेट को, प्लीज लॉक कर दीजिए। सॉरी, इन दोनों, ये दोनों वेव्स जब एक ही पॉइंट पे पहुंचेंगी, ये एक ट्रैवलिंग वेव है, ठीक है, ये कुछ ऐसे इनफाइनाइटली एक्सटेंडेड है, पर मैंने सिर्फ इतनी सी ही बनाई है अभी, ठीक है, इनफाइनाइटली एक्सटेंडेड। ये दोनों वेव्स एक ही टाइम पे एक ही पॉइंट पे अगर पहुंचेगी तो कैन यू थिंक कि एक रिजल्टेंट वेव होगी? रिजल्टेंट वेव मतलब आप ये बात समझो कि अगर ये वेव 1 है और ये वेव 2 है तो ये कुछ एनर्जी पहुंचा रही है। व्हाट इज अ वेव? दिमाग में क्या ध्यान में रखना है? एनर्जी पहुंचा रही है, ठीक है। ट्रैवलिंग वेव मतलब एनर्जी इज ट्रैवलिंग, ठीक है। तो हमें ये समझ में आ रहा है कि ये पहली वेव कुछ एनर्जी ला रही थी एक पॉइंट पे, ठीक है, ये दूसरी वेव भी कुछ एनर्जी ला रही थी एक पॉइंट पे। अब ये दोनों अगर एक साथ पहुंच जाएंगे तो व्हाट शुड हैपन? आपको कुछ ऐसी फीलिंग आनी चाहिए कि दिस एम्पलीट्यूड शुड इंक्रीज। एम्पलीट्यूड तो समझते हैं सब लोग, मैक्सिमम डिस्प्लेसमेंट की कुछ कहानी होती है, ठीक है। तो आप समझ पाओगे कि इन दोनों को अगर आप एडिशन कर दोगे तो यू विल गेट दिस डॉटेड इंक्रीज्ड एम्पलीट्यूड वाली लाइन, ठीक है। सेम वेवलेंथ, इंक्रीज्ड एम्पलीट्यूड, ये बात क्लियर है, ठीक है। व्हेन बोथ ऑफ देम कम एट द सेम पॉइंट, एंड ऑब्वियसली आपको ये दिख रहा होगा आई थिंक कि इन दोनों का फेज इज एग्जैक्टली सेम, फेज इज एग्जैक्टली सेम, दैट कंप्लीट बॉक्स kx minus omega t plus phi, that total term is exactly same for both of them। ये बात क्लियर है सबको, ठीक है। हाँ, थोड़ा छोटा बना। What is the phase difference between these two waves? What is the phase difference between these two waves? इसका कुछ kx माइनस ओमेगा टी प्लस फाइव की वैल्यू होगी, कुछ वैल्यू होगी इसकी भी कुछ अलग से वैल्यू होगी, kx माइनस ओमेगा टी प्लस फाइव, ठीक है। इसको 1 बोल देते हैं, इसको 2 बोल देते हैं। दिस वैल्यू 1 माइनस दिस वैल्यू 2 विल हैव अ वैल्यू, राइट। वो आपको देख के समझ में आ रहा होगा, व्हाट विल बी दैट वैल्यू। 0 होता तो वो दोनों आइडेंटिकल नहीं दिखती आपको, सेम फेज। अभी हमने जस्ट थोड़ी देर पहले बात करी कि इफ दे आर लाइक दिस, इफ टू वेव्स आर लाइक दिस, ठीक है, देन 1 minus 2 should be equal to 0, या फिर 1 is equal to 2, they have the same phase, ठीक है। Now I am just changing it a little bit, ठीक है। मैं अब ये कह रहा हूं आपसे कि let's figure this out। सॉरी, ये थोड़ा अच्छा नहीं बना है, बट प्लीज, ठीक है, आई थिंक इट इज एक्सप्लेनेटरी, ठीक है। तो आप प्लीज बताओ इन दोनों में व्हाट इज द डिफरेंस, प्लीज। बहुत आसान है, डोंट वरी अबाउट इट। जो आपको लग रहा है, लेट योर इंट्यूशन गाइड यू। क्या लग रहा है, कितना होना चाहिए इन दोनों के बीच में? सबने एसएचएम पढ़ा है? एसएचएम पढ़ा है? इस वेव को अगर मैं पाई बाय 2 आगे खिसका दूं, ठीक है, दिस पॉइंट इज कॉल्ड 0 पॉइंट, दिस पॉइंट इज कॉल्ड पाई बाय 2। साइनोसॉइडल कर्व है ना ये। अगर साइन कर्व होता तो साइन पे 1 की वैल्यू पाई बाय 2 पे आती है, 0 की वैल्यू पाई पे आती है। ये कौन सी वैल्यू होती है? 2 पाई होती है, ठीक है। अब आप ये सोचो कि इसके 0 पॉइंट पे और इसके 0 पॉइंट में क्या डिफरेंस है। अगर आप ये वेव यहां से स्टार्ट करोगे, इफ यू लुक एट दिस वेव, अगर आप ये वेव यहां से स्टार्ट करोगे तो इट विल कम आउट टू बी एग्जैक्टली एज दिस वन। आया मन में कुछ विजुअलाइजेशन आया? अगर आप इस वाली वेव को, ऊपर वाली वेव को पाई वाले पॉइंट से स्टार्ट करते तो यू वुड हैव गॉटन दिस वेव, है ना। ये बात तो क्लियर है, आई होप, ठीक है। तो डेफिनेटली आप कह सकते हो इन दोनों का डिफरेंस, डेल्टा ऑफ द फेज शुड बी इक्वल टू पाई, ठीक है। अब ऑब्वियसली मैं एक और आपको सिंपल सा आइटरेशन दे सकता हूं इसका कि मतलब अच्छा नहीं बन पा रहा है, बट ठीक है, काम चला लेते हैं। अब बताओ इन दोनों में फेज डिफरेंस क्या है? खिसकाने वाली बात सोचो मन में, कितना खिसकाना है आपको ऊपर वाले को, या कहां से स्टार्ट करोगे आप ऊपर वाले पे ताकि आप इस वाले पे आ पाओ। ऑब्वियसली आपको दिख रहा होगा ये ऐसा कुछ शेप चाहिए आपको, तो यू द फेज डिफरेंस शुड बी पाई बाय 2, ठीक है। इंपॉर्टेंट थिंग इज राइट दिस डाउन दैट व्हेन two waves are superimposed समझते हैं ना सब लोग, they are being applied या they are reaching the same point at the same time, ठीक है। the same point मतलब x coordinate, same time मतलब time का instant, ठीक है। क्योंकि हमारी इक्वेशन में आप देखोगे kx माइनस ओमेगा t है, ठीक है। तो we have two variables, one of them is time, one of them is the x coordinate, ठीक है। so when we are talking about superimposition, it automatically means कि they cannot be superimposed जब तक वो दोनों सेम पॉइंट पे, सेम टाइम के इंस्टेंट पे ना हो। समझ रहे हो, जैसे दोपहर के 1 बजे ही दोनों को एक पॉइंट पे पहुंचना होगा। ऐसा तो नहीं हो सकता ना कि एक वेव 1:10 पे पहुंची, एक वेव 1 बजे पहुंच गई। दैट इज नॉट सुपर इम्पोजिशन, क्योंकि दोनों एक ही टाइम पे एक ही पॉइंट पे पहुंचे ही नहीं जब तक, तब तक यू आर नॉट गोइंग टू कॉल इट सुपर इम्पोजिशन। ठीक है, इज दैट क्लियर? ठीक है, तो क्या कह रहा था मैं? When two waves are superimposed, comma, with a phase difference of 2n pi, 2n pi, 2n pi मतलब integral multiples of 2 pi which will be 0, 2 pi, 4 pi etc. ठीक है, so क्या कह रहा था मैं? When two waves are superimposed with a phase difference of 2n pi, comma, it is called constructive interference. It is called constructive interference. It is called constructive interference. ठीक है, फिर नेक्स्ट स्टेटमेंट आप लिखो, क्या लिखोगे बताओ? नेक्स्ट स्टेटमेंट बताओ, नेक्स्ट स्टेटमेंट. When two waves are superimposed with a n pi, 2n plus 1 times pi. ठीक है, it will be called destructive interference. Perfect. लिखो जल्दी से. When two waves are superimposed with a phase difference of 2n plus 1 times pi, the superimposition is called destructive interference. ठीक है, आगे बढ़े. एक और छोटी सी बात कर लेते हैं. अगर एक ट्रैवलिंग वेव है गिवन बाय y इक्वल टू a साइन के एक्स माइनस ओमेगा टी प्लस फाइव, ठीक है, तो इसमें व्हाट इज k? व्हाट इज k? k क्या होता है? कांस्टेंट होता है. हाँ, मेरे को पता है कांस्टेंट होता है. व्हाट इज इट इक्वल टू, और हाउ कैन आई फाइंड आउट द वैल्यू ऑफ k? डायमेंशनल एनालिसिस पढ़ा है आप लोगों ने? 12th में आ गए हो अब तक, डायमेंशनल एनालिसिस समझ में आना चाहिए. साइन के फंक्शन के अंदर मीटर के डायमेंशन का हो सकता है अंदर कोई टर्म? साइन ऑफ समथिंग अगर लिखा हुआ है तो अंदर डायमेंशन लेस क्वांटिटी होनी चाहिए, ये पता है सबको? डायमेंशन लेस होनी चाहिए. x अगर x कोऑर्डिनेट है, x अगर x कोऑर्डिनेट है, उसका डायमेंशन क्या होगा या यूनिट क्या होगा? डायमेंशन इज सेम एज यूनिट. मीटर, x का यूनिट मीटर हो जाएगा. आपको ये समझना चाहिए कि k इंटू एक्स का यूनिट क्या होना चाहिए? डायमेंशन लेस होना चाहिए. ठीक है, तो आप उससे भी कुछ सोच सकते थे कि इट हैज टू, k हैज टू बी 1 अपॉन मीटर. ठीक है, k अगर आपको याद होता तो इट इज 2 पाई बाय लैम्डा. कुछ होती है ऐसी कहानी. ठीक है, ओमेगा क्या होता है? 2 पाई बाय, इस ट्रैवलिंग वेव की स्पीड क्या होगी? व्हाट विल बी द स्पीड ऑफ दिस ट्रैवलिंग वेव? स्पीड का यूनिट क्या होता है? मीटर पर सेकेंड, ठीक है। तो अगर मेरे को मीटर पर सेकेंड लाना है तो मैं ये समझ सकता हूं कि लैम्डा विल बी इन मीटर्स एंड टाइम विल बी इन lambda by t. This is how I remember it, ठीक है। This is not the derivation, this is how you can remember it, ठीक है। और lambda by t है, lambda को आप क्या लिख सकते हो, 2 pi by k, इसको उधर ले जाओ, इसको इधर ले आओ, ठीक है। lambda को आप लिख सकते हो 2 pi by k, this will come out to be omega upon k, ठीक है। लिख लो जल्दी से ऐसे ही। Okay, I didn't know that. I'm so sorry. ठीक है, can I erase this? आप सब कंफर्टेबल हो? All of you are comfortable with English? Are you sure? हाँ? ठीक है, तो आई थिंक वी हैव डन अ लॉट ऑफ ग्राउंड वर्क नाउ, ठीक है। वी कैन नाउ फाइनली स्टार्ट यंग्स डबल स्लिट एक्सपेरिमेंट। सो देयर इज समथिंग कॉल्ड अ कोहेरेंट सोर्स। कोहेरेंट सोर्सेस sources of wave with constant, usually zero phase difference यूजुअली जीरो। कोहेरेंट का मतलब यूजुअली जीरो होगा फेज डिफरेंस आपके दोनों सोर्सेस के बीच में। ठीक है, नाउ लेट्स सी द सेटअप। द सेटअप इज गोइंग टू बी समथिंग लाइक these are called slits. This is called a slit. Slit is like very small opening. This is a very small opening. Both of them are slits, ठीक है। And bang in the middle of these slits there is a source. There is a source and this is a screen. What is the purpose of the slits in this setup? बता सकता है कोई? एक सोर्स से हाउ मेनी वेव्स आर एमिटेड फ्रॉम अ सोर्स? इनफाइनाइट, ठीक है, क्लियर है। द पॉइंट इज दैट वन सोर्स विल ऑलवेज प्रोड्यूस वेव्स ऑफ द सेम फेज, ठीक है। सो द मोर इम्पोर्टेंट थिंग इज, आई थिंक समथिंग दैट शी मिस्ड इज कि वी डोंट जस्ट वांट टू सोर्सेस, वी वांट टू coherent sources, ठीक है। remember this, please remember this, we are making these slits so that we have two coherent sources, ठीक है। try to understand that there will be one wave which will go here sorry, one wave which will go here, okay? And now these are two sources which will emit waves. Now we have, rather than having one, now we have two sources which will emit waves of same phase या zero phase difference, ठीक है? Same phase या zero phase difference, ठीक है? Now that is out of the way. This separation between the two slits is called small d. Usually, this is like the convention that is used to explain it everywhere in all textbooks and across whatever material. Okay? This separation is called capital D. Clear है? ठीक है? Now the point is that say, ठीक है, I'm going to take a random point. This is a random point at a height y. I'm going to call this height as y. ठीक है? At a random height y, I want to find out what will be the intensity of intensity of the superimposition. दो waves जब superimpose होंगी, when two waves are going to reach the same point, try to understand, there will be a wave coming from here, there will be a wave coming from here. Agar if you think about symmetry, then obviously the most obvious point is this one, that this one will be identical for both of them. Okay? So if there is a wave that is coming from here and if there is a wave coming from here, both are going to travel the same distance. Okay? If both of them are going to travel the same distance, there is going to be zero phase difference here also. Okay? That will not be true everywhere else. The problem is that will not be true everywhere else. Why? Because say, just for example, if we are talking about this point, then let me take a line which is going like this. Okay, this is depicting the wave coming from this source. Now I can also send another wave. Okay, and just for reference, I need to just join this also. The important thing here is that in this whole mathematical explanation of the experiment, D is taken very, very less than capital D. Okay, this is important. Write down when two waves are superimposed, when two waves of intensities I1 and I2, when two waves of intensities I1 and I2 are superimposed, when two waves of intensities I1 and I2 are superimposed, the intensity of the resultant wave, the intensity of the resultant wave bracket due to superimposition. The intensity of the resultant wave due to superimposition is given by I net equal to I net equal to I1 क्या होता है? Does anybody remember this formula? Please write that down. I1 plus I2 plus ठीक है. Thanks for helping me out. ठीक है, ये मिटा दूं? Right. Perfect. Also, I think you should know that I is proportional to amplitude to the power square. ठीक है? Also write this. ठीक है? If I1 is equal to I2, okay, just I'm going to do this right now. I1 is equal to I2, we will get I plus 2 root I square cos phi. Okay, I just put I1 equal to I2 equal to I. Okay, so this will become 2I times 1 plus cos phi, which will become 1 plus cos phi, which is of the form cos of twice of phi by 2, 1 plus cos 2x, 1 plus cos 2x is 2 cos square x. ठीक है? So I can come to 4I cos square phi by 2. Where phi is, what is phi? Phase difference between the two superimposed waves. Now the problem here is that at a distance y, okay, there is a random point that we have chosen. Okay, now at this point, the problem is that although both these waves were initially coherent, they were having the same phase. The problem is that this wave, this particular wave, is going to be traveling a bit less distance compared to this wave. Okay, how can I find that distance out? I'll simply drop a perpendicular to this point. Is this clear? Okay, if this length is say x, this length will be delta x. I'm just denoting it with delta x, and this will again be x. Will it be x? It will be nearly x. Okay, this is an approximation. When you assume that small d is very very less than capital D, okay, the point that we are understanding is the point that I'm trying to make you understand is कि when small d is very very less than capital D, this line, try to understand, this line, and this line, all three of them are nearly parallel. You are considering them to be parallel. I know it doesn't feel right, but these are considered to be parallel when the approximation is that D is very very less than capital D. Okay? Now the problem is that although initially the first wave was a sine omega t minus kx, ठीक है? I'm just assuming that phi is 0 just for simplicity, and this particular, the source below y2 is a sine omega t minus kx. The problem is that at this particular point, the second wave y2, this wave that is coming from here, okay, it is not traveling a distance x. Okay, try to understand कि this wave, the wave above, traveled a distance x. This wave, the wave below, will travel a bit more. How much more? X plus delta x. Okay, I hope this is clear. So I will not write x here. Okay, I hope this is clear. I will write x plus delta x. That's it. Okay, simple enough.
Previously you have told the equation it was in bracket kx minus omega t. And here omega t minus kx. It is the phase.
दोनों में क्या डिफरेंस है? पाई. Don't worry about that. ठीक है, if you want, it is the important thing is कि omega t minus kx and kx minus omega t are only separated by a phase difference of pi. Both will be traveling in a plus x direction. ठीक है, so just remember that if the signs are opposite, then the wave is traveling in plus x direction. If the signs are same, if both had been negative, yeah, both had been positive, then it would have been traveling towards negative direction of x. Okay, please remember this. So okay, we are here. Okay, there is a question how these lines are parallel. I'm just coming back that D is very very less than capital D. This is an assumption that is being made due to the setup. So because of this, you are going to assume that all three lines are nearly parallel. Matlab, it is an approximation. Anyways, so this is where we are right now. Now what we can do is, what can we do? We just some time back studied constructive interference and destructive interference. Okay? So the point that we made was that for two waves to constructively interfere, for two waves to constructively interfere, what should be their phase difference? 2n pi. Remember, 2n pi, not 0. 2n pi. N mein, if you put n equal to 0, you will automatically get 0. Okay? So don't worry about that. Just stick to 2n pi. Okay? Now try to understand that once you open x plus delta x, okay, what you will get is, I'll just open this for you, omega t minus kx minus k delta x. Is this clear? Okay? Now obviously now you can observe that this phase, the phase of the first wave and a part of the phase of the second wave is same. Okay? The phase difference is obviously k delta x. That is clear now, I hope. Okay? So if the phase difference is k delta x For constructive interference, you want k delta x to be, okay, and for destructive interference, you want k delta x to be 1 times pi. All right, please write this down. Please keep writing everything down. If I'm writing something, you have to write it down. No questions asked. Please don't wait for me to say, go ahead and write this. Listen to it, but at the same time, once you have understood something, write it down. Okay, now I will rub this y1, y2 thing. All right. Now I'll just come back to the whole picture. Okay, why we are studying YDSE was, why were we studying YDSE? To prove that, because this experiment was fundamental to proving that light has a wave nature also. Okay. Then the point of this experiment was that try to understand the way science works is, first you do an experiment, all right, then you formulate a theory, and then you try to predict the results that you already got using your theory. All right, so what Young did was that he took this exact setup. All right, now what he did was replicated this complete experiment, put a source here, made 2 slits here. All right, now what he observed, I'll just clarify this. What he observed was that there were some patterns of maximum intensity, minimum intensity, maximum intensity, minimum intensity. What will this x point be, maximum or minimum intensity? For maximum intensity, do you want constructive interference or destructive interference? Constructive. Will this point be constructive interference point or destructive? The waves are going to come from here. They are initially having same phase, and both are going to travel the same distance to come at this particular point, only this point. All right. So will this point be constructive interference or destructive interference? This will be a point of constructive interference. Okay. Now what he observed in the experiment was that this was a bright spot. He called it a bright spot. All right, this was a bright spot. Then the intensity reduced until this was a dark spot. This was a bright spot, this was a dark spot. Then intensity increased for a bright spot, and this alternated. All right, now I am showing this on a straight line, but try to understand that light does not go in a straight line. Light will go in all directions. So basically, if you took a screen and if you viewed it from the front, like you are viewing this board, you would have seen that there is a bright spot here. You would have seen that this brightness is dulling away. All right, and then there is another bright spot at some distance. All right, then there is another bright spot at some distance. Try to understand that when you are saying this is bright, dark, bright, all right, you are only talking about this particular line. Do you get my point? If you rotate this particular line 360 degree, you will get these circles. Is my point clear to you? If you rotate this line 360 degree, you will get these circles. Am I clear? All right. Okay, I'll drop this. हाँ, so the only point now is that maybe we should try to formulate these values of delta x, you know, because I want to find out where the bright spots are and at how much distance from this point, you know, those kind of patterns I just want to formulate mathematically. So what I will do now is I will just go through a series of approximations and mathematical, you know, way of proving whatever I'm going to prove now. ठीक है, तो now I assume this angle to be theta, and assuming that these two lines are also parallel. We just said this earlier that this line and this line, let's just give them names. I will call this point S1, I will call this point S2, let's call this point as A, call this point as B, let's call this point C. Okay, perfect. Now what we can do is if these two lines are parallel, what will this angle be? If I am assuming that S1B, AB and S2B, all three of them are parallel, and you have assumed that angle BAD, I am calling this point as D, angle BAD is theta, this line S1B is parallel to AB, alright, what should this angle be? Theta, corresponding angles, okay, it should be theta, perfect. If two lines are parallel and there is a perpendicular drawn to one of them, will it be perpendicular to the other parallel line as well? If there are two parallel lines and I draw a perpendicular to this one, this has to be perpendicular also, okay? So now what I can say is that since S2B is parallel to S1B, alright, S2B is parallel to S1B is parallel to AB, this should also be a right angle. Also, this should also be a right angle. Are you getting this? Is this clear to everyone? Okay. Now if this is 90 degrees, then what I can say is that what will this angle be? 90 minus theta. What will this angle be? 90 minus 90 plus theta. Theta आ जाएगा, ठीक है? You get this as theta. So from this assumption as theta, we have come to this point that in triangle S1 S2C, the angle S2 S1C is also equal to theta. ठीक है? Please just make a note of all these things. ठीक है? You will not remember how you did this derivation. ठीक है, can we move on? Now we have proven that this particular angle S2 S1C. S2 S1C is also theta. Now I'll just go a bit quicker. In this particular triangle, we know the value of small d. Okay, we know the value of S1 S2. The length S1 S2, we have taken that to be small d. Okay, and obviously we'll be able to measure it. So can I express delta x in terms of d and this angle theta? I can, but you will have to tell me what is the answer. Please tell me. Delta x is equal to that's it, delta x is equal to sine theta. Small d times sine theta. Okay, perfect. After this, you are supposed to make a note. Just make a note that since capital D is very greater than small d, since capital D is very greater than small d, how long does this class go on? 2:10 is the time. 2:45. मैं क्या कह रहा था? Since capital D is very greater than small d, the angle theta will be very small. The angle theta will be very small. And for small angles sine theta I will first approximate as theta, and then theta I will again approximate as tan theta. Okay, this is a two-way assumption. Can I rub this, please? So I will take, instead of now sine theta, I will directly write as tan theta. D tan theta. Now I will come back to the larger triangle BAD. Triangle BAD, is it visible? BAD. ठीक है? In triangle BAD, you can obviously write tan theta, express tan theta in triangle BAD. Y upon A AD has been assumed as something. Is it clear? Okay, now I'll make this substitution. Delta x is equal to d small y by capital D. ठीक है, can I move on? क्या कह रहा था? हाँ, so now obviously we are done, almost done. We have found out the value of delta x in terms of the y coordinate. ठीक है. Obviously if this distance is y, then this is also the y coordinate, ठीक है. It is not a problem for us. Now I will just first go for constructive interference, which will give us a bright spot or a dark spot. Bright spot, ठीक है. Constructive interference will give us bright spots. All right. So I will just substitute delta x from here. All right. So I will get k times, and k also has a value. When we were revising, I said 2 pi by lambda. All right. Now I will substitute k as 2 pi by lambda and delta x as dy by capital D. All right. Taking this whole thing, 2 pi by lambda times d small y by capital D equal to 2n pi. ठीक है. This is only valid for constructive interference, please, for the final time. ठीक है. And then obviously you can start cutting some things out. And this can be simplified into y equal to n lambda capital D by small d. And obviously you remember that for constructive interference I could have used any integral value of n, 0, 1, minus 1, whatever, ठीक है. So obviously that carries over because n was introduced here with a set of 0, minus 1, plus 1, plus 2, minus 2, you know. So that n gets carried over here. All right. So the first value of n that I will put is 0. ठीक है. So obviously you know that for what is this y equal to n lambda d by d standing for? These are the bright spots. Putting different values of n, you will get different values of capital Y at which you will find the bright spots. Is that clear? ठीक है. हाँ. So first bright spot n equal to 0, y equal to 0. Proven. ठीक है. अभी तक हम we were just using symmetry and but now we have mathematically proven it. ठीक है. Math, in terms of maths we have proven it. All right. Now another important thing is that if the first bright spot is here, where is the second bright spot? N equal to 1 at a distance of lambda capital D by small d. All right. So for the bright spots, first bright spot is at 0, second bright spot is at lambda capital D by small d. Now the important thing is that the first bright spot was here, then there was a dark spot. Maybe we'll just come to the dark spots, but for now you can assume that there will be a dark spot in between. All right. There was a bright spot, a dark spot, a bright spot. All right. Now the distance between two consecutive bright spots or the distance between two consecutive dark spots is called fringe width. Okay, please make a habit of studying whatever topic you are going to be taught before you come to the class. Okay, please try to inculcate this. Fringe width is the name given to the distance between two consecutive bright spots or dark spots, and obviously now we know that the first one was at a distance equal to 0, second bright spot was at a distance equal to lambda capital D by small d. This is done. Clear enough? Okay, this is done. I'll just rub this part off. Now we have done the bright spots, या फिर the constructive interference. All right. Now I'll just come to destructive interference or the dark spots. So for destructive interference, I will again make the same substitutions. K is 2 pi by lambda. Delta x was dy by capital D. Just please have a look into your notes. Huh? This is correct. K delta x should be equal to 2n plus 1 times pi, and then you can erase some things. Okay, and then please just simplify this. बताओ बताओ जल्दी बताओ. Y equal to 2n plus 1 lambda capital D by small d. सही है? Or there should be another 2. So let's try to just confirm fringe width. All right, we have done it for bright spots. We can do it again. Okay, so where is the first dark spot? Where is the first dark spot? N equal to 0. N equal to 0. Lambda capital D by 2D. All right. So I'll just rub this. So the dark spots are at y1 is lambda capital D by 2D, y2 n equal to 1, 3 lambda capital D by 2D. Subtract y1 from y2. I think you will be able to come to lambda capital D by small d. All right. Again coming to fringe width. All right. This the same thing. This is for the dark spots. These are the distances for the dark spots. After this, just write a small variation 1. Just write variation 1. This complete area, variation 1 is that this complete volume between the slit and the screen is filled with a medium of refractive index mu. The volume between the slits and the screen is filled with medium of refractive index mu. What is the change in fringe width? Exact change. What will be the new fringe width? If initially there was vacuum, all right, so we have found out that fringe width will be lambda capital D by small d. When we filled that complete volume with a medium of refractive index mu, what will be the new fringe width? Will it be changed? Will it remain the same? How? What will be the new fringe width? How to think about it? What do you know about fringe width? One formula. Distance can change. Can distance change? Only lambda will change. What will be the effect on lambda? What will be the effect on lambda? Is wavelength going to increase or is wavelength going to decrease, and by what factor? So lambda nu, I just like to call it lambda, you can call it whatever you want, will be lambda upon mu. I don't know if this has been taught to you, but this is what happens. All right, so if you are going to insert a medium of refractive index mu, the wavelength of the wave will change. All right, it will become lambda by mu. So obviously now you can say that the new fringe width will again be lambda capital D by small d, the original fringe width, simply divided by mu. Okay, so it is going to decrease. I hope you can see this. Variation 2. Variation 2. Red light and violet light are used. Red monochromatic light and violet monochromatic light are used. Okay, which one will have the greater fringe width? Which one will have the greater fringe width? Red. Q. Why? Lambda of R, red, is greater than lambda of violet. Therefore, fringe width of red should also be greater than fringe width of violet. Simple enough. Variation 3. Source is moved closer to the slits. Source is moved closer to the slits. Is moved closer to the slits. So what do you think should be the effect on fringe width? Try to think analytically. Just look at your diagram. Look at what do you think should happen if the original source S will be moved, if S is being moved closer to the slits. All right, what is going to be the change? Okay, so now you can write down the result. No effect on fringe width. No effect on fringe width, but intensity of bright spots will increase. फोर्थ वेरिएशन कौन सी चल रही है? फोर्थ ही चल रही है. फोर्थ वेरिएशन, सोर्स इज वाइट लाइट. Fourth variation, source is white light. What is white light? Technically, it is a combination of all the monochromatics, Vibgyor, whatever. Okay, so now think about it. Ki what kind of pattern will you observe if the source is white light? There is everything present. Red is also present. Violet is also present. You know, just talk about red and violet, and I think it will be enough. Just think about what is going to happen, what kind of a pattern will be observed, and why, and everything can be related just using fringe width. You can come to the assertion just using fringe width. बताइए. Just talk about violet and red. ऊपर बनेगा, नीचे बनेगा. With respect to what? किसके रिस्पेक्ट में कह रहे हैं आप? जैसे मान लेते हैं दिस इज माई स्क्रीन, ऑलराइट, दिस इज माई सेंट्रल पॉइंट, ऑलराइट. नाउ ऑब्वियसली हम रेड और वायलेट कर लेते हैं, बाकी विल ऑटोमेटिकली फॉल, ऑलराइट. We know that fringe width for red will be greater than for violet. Perfect. The point is, first point in such a case when you are going to use white light is, this will be a white light spot. This will be a white light spot. Why? Why will this not be any different color? Exactly. Try to understand कि fringe width comes into effect when you are considering two consecutive ones. All right. Now this is going to be common for each of them. Even for red, this will be the bright spot. For violet also, this will be the white spot. The problem comes when you go to the next ones. Here the problem starts when you go to the next ones. All right. Now we know that the fringe width, या distance between two consecutive bright fringes for red is greater than the distance for two consecutive violet fringes. ठीक है? So obviously I can say that the next red bright spot will be here. Violet will be here. ठीक है? Violet to red there will be a transition. Are you able to understand my point? पक्का? ठीक है? So just write this down. Central fringe has to be white light, will be white, will be a spot of white light, will be a spot of white light followed by rings. Rings क्यों कह रहा हूँ? I think I am pretty clear. I showed you that thing, circular वाला. ठीक है? So followed by rings of first. पहले कौन से कलर की रिंग आएंगी? Violet, and then they will transition into red. All right, and it will be a continuous transition. ठीक है? Try to understand this. It will not be a discrete transition. What is a what is a discrete transition and what is a continuous transition of these rings? Say for example, this is your coloring board. All right, what you did is you colored this part completely red. Then you colored this part completely some other color. All right, now then you colored this part something, then you colored this part something. This is violet. ठीक है? Continuous, this is discrete, this is not continuous. ठीक है? Why? Because there is a boundary. Can you see the boundary? For a continuous variation, you would need shading. शेडिंग समझते हो आप लोग? बचपन में ड्राइंग करी, ठीक है? तो उसमें शेडिंग नाम का कोई कॉन्सेप्ट होता है ना, दैट यू मेक इट अ कंटिन्यूअस ट्रांजिशन. ठीक है? तो ट्राई टू अंडरस्टैंड दैट इन दिस पर्टिकुलर क्वेश्चन व्हेन यू आर गोइंग टू यूज व्हाइट लाइट, ठीक है, देयर विल बी अ कंटिन्यूअस ट्रांजिशन. ठीक है? दीज आर जस्ट स्मॉल पॉइंट्स, बट समहाउ इफ यू नो दे कम यूजफुल टू यू, देन इट विल बी गुड फॉर एवरीवन. ठीक है? एनी क्वेश्चंस अबाउट YDSE? Any part in this whole derivation that you did not understand? Which one? White light. Okay. The audio is clear, I hope. Okay. So my point is that if you are taking a source of white light, then for the source to be white light is nothing but a combination of violet, red, all right, multiple monochromatic lights all mixed together. Now for all of them, first take violet, then take red. You know, if you want to think about it simplistically, take violet, then take red, take different colors. For all of them, this point will be the bright spot. Okay? And because for all of them, we know that the fringe width will be different. Okay? So the next bright spot for red will be here, and the next bright spot for violet will be here. So what I can see is that it will come out to be something like this. It will be a ring of violet, then a ring of red. All right. So I don't think we will ever have another white spot. We will only have this white spot, and then you will have different rings for different colors. All right, and just make a note of this. All right, just I hope you made a note of this. All right, please just go through whatever you have studied today. Just anything, if there is anything that you feel is unclear, any doubts, you can ask me right now. Don't rush through it. Go point by point. But there will be no effect on fringe width. let's just put to explain this. I'll just have to teach you something else. I don't know if it has been taught or not. You can tell me if it has been taught. All right. Uh, there's something called a wave front. All right. This is part of your competitive syllabus. So the point is, let's assume for a second that there is a point source of light or wave or whatever. Okay? If I tell you, and I think it will be intuitive to you, okay? If you think by intuition, you will be able to guess that its wavefront will be spherical. Why? Because for a point source of light, all directions are same. There is no distinction between any direction. All right. So light will be equally sent in every direction. I hope this is clear. All right. And if you make a line perpendicular and connect those perpendicular lines to all directions, you will form a circle. Is this clear? This was a कैसा source था ये? This was a point source. ठीक है? And the wavefront that we got was spherical. ठीक है? Now tell me something. Let's assume, just for a second, that there was some E amount of energy, capital E amount of energy that was released by the point source, and it has reached this spherical wavefront. All right, this is coming out as a spherical wavefront. What is the energy per unit area? It is called intensity. Intensity of a wave is energy per unit area. Is this correct? Is this correct? Intensity is energy per unit area. All right. Now, if E amount of energy was released, all right, and that energy has, say, just for just for argument, that energy has traveled a distance r, radius, whatever. What can I say this to be? E upon, what is the area of a sphere? स्फीयर का सरफेस एरिया. All right. And obviously now you can see that the intensity for a point source decreases with distance. Decreases with distance. So now coming back to my point, the point in variation 3 was that there is a point source and you are going to bring it closer to the slits. Okay, so if R is being decreased, I hope now you can see that if you are bringing it closer, R is being decreased, intensity has to go up. Okay, was this ever taught to you? Intensity बताई थी, intensity is going to decrease with ऐसा कुछ. चलो कोई नहीं, आप लिख लो, please write this down. बेटा आपको कुछ समझ में आया? प्लीज नोट्स कॉपी कर लेना आप अपने फ्रेंड से, ठीक है? ठीक है, नाउ यू कैन quickly find out intensity as a function of the distance. जैसे हमने यहाँ पे intensity as a function of distance निकाला है. Please find it out for line source. For a line source, this was a point source of light या point source of wave. Find it out for a line source. लाइन सोर्स का ऑब्वियसली कुछ लोगों ने सोच लिया सिलेंडर फॉर्म में आना चाहिए वेव फ्रंट, जैसे इसमें स्फेरिकल आना चाहिए वैसे ही एक लाइन के लिए, एक स्ट्रेट लाइन के लिए सिलिंड्रिकल होना चाहिए. प्लीज फाइंड आउट इंटेंसिटी एज अ फंक्शन ऑफ डिस्टेंस. ठीक है, इस पर्टिकुलर सिलेंडर के लिए ऑल डायरेक्शंस आर समवॉट सेम एंड देयर विल बी अ स्फेरिकल सिलिंड्रिकल वेव फ्रंट. क्या हो गया, इतना टाइम नहीं लगना चाहिए. What is the surface area of a cylinder? 2 pi. Obviously आप ये बात सोच सकते हो कि no energy is being sent in the vertically upward or in the vertically downward direction. It is a line source like a tube light. So your tube light will, अगर आपकी tube light is like this, all right, it will never send light in this direction. Obviously आपने घर पे भी देखा होगा that if you have a tube light, then you will never have energy, light just to the left or just to the right. All right, ठीक है, this is a fair enough assumption. So what is the curved surface area of a cylinder? 2 pi r into h. ठीक है, intensity upon area for a cylinder, this is a line source cylindrical intensity E upon 2 pi r h, and h is fixed. So for a cylindrical wave front it will be I is 1 proportional to 1 by r. All right, now the next one should be a square panel, and you will now understand that why we have square panels in this room instead of tube lights or bulbs. Obviously you can see the intensity is decreasing with distance. All right, what is the highest decrease? It is for point source, 1 by r square. All right, it is going to have the most decrease, point source. Lesser decrease will be for a line source or a tube light. ठीक है, if you go for a square panel, all right, instead of a line source, if you go say for a square panel, all right, now the thing with this square panel is that it will somehow send energy only perpendicular to its surface. All right, so if E energy was sent here and it is being sent perpendicular to the surface, it will always maintain the shape from which it is being sent. So for a square, rectangular, basically planar source, for a planar source, I is constant with distance. That is why you have these kind of illumination panels now, more and more. This is more effective, more efficient. All right, you have better illumination on your notebooks. Any other doubts? Please go through your notes. Any other doubts? क्लियर इनफ? श्योर? चलो ठीक है, थैंक यू सो मच. This class is over. Thank you. अच्छा, there is this one गंदा सा formula that I is 2 pi rho c mu square a square. This is amplitude. This is frequency. Speed. Speed of? Speed of wave. हमने निकाली थी अभी स्पीड ऑफ वेव थोड़े टाइम पहले, लैम्डा अपॉन कैपिटल टी या फिर ओमेगा अपॉन के. ठीक है. रो इज, व्हाट इज रो? कुछ तो है, डेंसिटी. ठीक है. जस्ट यू शुड नो दिस. ठीक है, आई एम जस्ट टेलिंग यू, जस्ट ट्राई टू कीप दिस इन माइंड. ठीक है, थैंक यू सो मच. Density of the medium in which the wave is traveling. Density of the medium in which the wave is traveling. Do I have to do this also?
Not only you can
Only this.
yeah.
That also. Alright, I'll do it somewhere else. Thank you. हाँ. ये बताइए, आपका नाम क्या है?